my name is Evan Clary, and I'm here with Michael Clary and George Mills, and we are starting a production roundtable to discuss questions about machinery in the corrugated industry. We're talking about non-specific make or model, but we're talking mostly about converting equipment and corrugators, and we're here to answer questions from the community. So we've got some questions to start here today. We're going to be posting these questions bi-weekly for the foreseeable future through containerboard.com and on our YouTube channel. The first question, how much warp is too much to practically run, and how do we best run it?
Well, I think, Evan, mostly you've got to rely on individual machine manufacturers generally give you a recommendation on the maximum amount of warp the machine should be able to tolerate. So they'll give you some specification and guidelines for that. Has that been your experience, George?
Yes. Each vendor tends to resolve around a number, but there's no real proof as to where that number originated. The FBA says 1/4 inch and 12 inch in any direction. Tappy, on the other hand, has a formula that gets convoluted with a square factor in it. So a warp factor of 1/4 for Tappy means something totally different than warp factor of 1/4 for FBA. You have to decide which one is which, have an agreement with your people. Most people have designed their machines for the 1/4 in 12.
Well, I think we'll all agree that flat sheets are ideal, but often that's not the real world, particularly with sheet plants having to experience the corrugator at one location and then being transferred, and time difference and different conditions in the transfer. But I think the big thing we've got to keep in mind too is even if the machine will tolerate it, we've got to make a good box for the customer. And excessive warp is a big problem on the quality of the finished product.
Good boxes is definitely the most important part of that. So the longer that people tend to wait after the sheet is made off the corrugator, the worse the sheet is, and then you can run it into some cracking and things like that. So how do you suggest that people run warp if they have to run warp through their machine?
Carefully. but you know, I think, in fact, George and I were recently talking about this on things. Before we had lead edge feeders, some ways the feed section would eliminate sheets that were too warped. And then we came along with E-flute and things like that to run, and we developed lead edge feeders. Then we developed vacuum transfer for all these very lightweight, challenging things to feed and transfer. So therefore, not only would they handle microflutes, then they would also handle warp better in certain ways. But you still just take it to the next level because you may be able to feed it, you may be able to get it through the printer, but you start hitting the same obstacles when you're in the slotter and the die cutter. So it's just where you want to deal with the problem.
Understood. Yeah, decreasing machine speed can be a good way to deal with warp from my experience.
Yeah, it's always tough, you know, because some people feel like they want to kind of throw the machines through the machine, but certainly as it gets into the folder and other places at speed, you can precipitate more jams and maybe more severe jams.
All right, we'll move on to question number 2. What is the best practice for diagnosing registration issues?
Well, I guess we've got to think at first, you're really looking at your first blank as compared to the spec. So let's assume everybody gets their first blank adjusted to the specification. But generally, when we talk about registration problems, we're talking about blank to blank variation. You start seeing something where the machine is not consistently producing the same printing or die cutting or slotting kind of thing. So the blank is moving around. And that way you've got to kind of walk back through the machine and look at some blanks, and everything you should be measuring off the lead edge of the blank. So the leading edge as it went through the machine. So you're kind of reading like a roadmap of where things went wrong. Is it printer 1, printer 2, the slotter, the die cutter? Is it going through squarely? Is it skewing? Or is it just hesitating or not and carrying through? So kind of the irregularity of it and where it occurs should tell you where to look.
So what you can do is take a look at the machine manufacturer's specification that they provide. And then if you're experiencing that irregularity, measure the irregularity and see if it's outside the acceptable limit of what the machine manufacturer provides. And then you can know if you've got a real issue.
Exactly. Well, that would be just, you know, within the tolerance of the machine build itself. The other is if you have some kind of problem, something that's varied, you know, that you haven't recognized. The other thing, George, you know, we've talked about looking at fingerprinting, checking machines, and kind of historically keeping machines if they're older machines, particularly, so that you really know what to expect out of them.
That's correct. Is if you fingerprint a machine and save it, or save the first one when everything's nice and new, you can actually measure the degradation that you're coming up with through wear and tear on the machine. And a good rule of thumb is at the point that you're through your own color, it's time to take doing something to correct it.
One of the good ways too, Evan, if you're having trouble on a certain job and so forth, trying to find out where the position is, and it gets very frustrating if it's under pressure and so forth to complete this work, is step back and do some kind of on-the-job testing with it in terms of getting more impression than you would normally. Now, it degrades the box, but it's going to guarantee control at the transfer nip. So, in other words, each element as you progressively go through the machine will have more and more nip pressure, but you adjust it beyond where you would normally run the blank, and that way you feel like you're eliminating the point-to-point transfer, because ideally we would like kiss impression, the least amount of pressure on the blank to adequately transfer, print, and process the blank through the machine. But when you're in the debugging process to see where maybe something is broken or something's in the machine interfering with the blank transfer, or just any number of things, sometime running and really wasting a few blanks, if you'll have it, can be very useful in quickly leading you to the solution rather than running hundreds of blanks that may not be saleable.
Yeah, no, I can understand how increasing that control would assist in identifying where the issue is. As you say, debugging. Definitely see that. The third question that we had come in is pretty interesting. It says, how effective is anvil grinding?
George, what's your impression on the anvil grinding? Are you a big proponent of that?
Well, you know, first and foremost is anvil grinding brings you back to a level of precision as the machine was intended to run. It comes at a cost. The cost being the replacement of anvil covers, probably more frequently than it would were you to just run without anvil trimming and say they're worn out.
Well, and then too, George, usually most all anvil grinding systems are coupled with servo speed correction.
That's
So
correct.
therefore, as we change the height of the anvil, we're adjusting for that. So we're getting better speed control, i.e. back to one of our registration points, you know.
That's correct.
One of the things to caution, it's always good because people like things perfect, and perfect anvil and anvil grinding looks very nice after it's done. But if the guy that's doing the grinding doesn't have to pay for the blankets, you don't want to do it more than is reasonably prudent in terms of a production measure. So it's always good to really put some kind of plant control or protocol in there so that you're not overdoing it, because the only one to benefit from that maybe is whoever's selling you the anvil covers.
True.
So with the machine installation, you know, they can set up some type of protocol with the maintenance department to, you know, set some type of timeline for how many anvil covers they think they should go through on this.
Yeah, you can do that, Evan. And also, you know, you can look at how many impressions the machine's run since you've done that. But the other thing, and it's not an absolute number, because let's say you had a super sensitive job, a new big customer that, you know, for whatever reason, the customer's requirements are just marketing to really get your foot in the door, wants pristine boxes and everything as perfect as it possibly could be. You may do it more in terms, or certainly do it right before those kind of critical runs, because that will refresh and get you in the optimum control and cutting. And I think too, George, you've recently on a job I saw, you know, you were noting the anvils looked pretty bad, and they were hanging up some of the scrap in the job because, you know,
Yeah.
and so you develop some other problems in that too.
So without anvil grinding, we end up with peaks and valleys on the anvil, which cause issues with scrap coming through the machine.
That's correct.
Exactly. And I mean, we rotate covers to get even wear from the inside out, because obviously, you know, not too many of the blanks run and have die cutting on the very extremes, but that doesn't totally, you know, level the surface like the grinding does. But you still have to keep up your normal rotation of covers.
Okay.
Well, it's actually a combination of the two, because if you have a wide machine and you only, let's say, the bulk of your die cut work is down the center 2/3, if you only rely on the anvil trimmer, you actually have your outside grinder covers going on new, being ground away to nothing, and then being replaced. So Michael's comment about the combination of rotating covers with anvil grinder being the best management approach is a fair one.
And usually now with the new locking systems, you know, rotating the covers is a pretty, you know, efficient, quick job. So the systems are quite good now.
I've seen a couple different systems as far as anvil grinding. You know, I've seen the diamond sand rolls. I've seen the sliding tooth that goes along. I've seen a couple different solutions. All right, question number 4. How do I improve registration without a total rebuild of the machine? This question came in, and I'm thinking it's probably more so in reference to older machines, older converting machines that somebody has in their facility. So an older Flexo folder gluer or rotary die cutter. And my first thought on this is that it's important to fingerprint the machine from time to time so that you understand where you are. What do you think?
Well, I think, you know, it's a good question, because certainly somebody can come in and say, we can fix up this older machine, but it could involve hundreds of thousands of dollars and progress even beyond, because generally there's not even a clean estimate sometimes, unless it's extremely on the high end, because things are discovered as the work progresses. But what you can do is a number of practical things to try to do it, just as you were talking about fingerprinting the machine and realizing where you are. Certain things are practices, like, you know, particularly on an older machine, any machine you should not, but particularly an older machine, you don't want to be changing speeds while the job is running, because you build up certain lost motion between things, like gears. Play in the gears is a bit more. There's wear in different places. So once you're running and not varying the speed, a lot of that is minimized unless there's jostling and changes, but change of speed does create that. So you really want to get the machine at the speed you intend to run it, run a blank through, make sure you're on register, you're good, and then leave it alone with the speed and keep going. And then further to that would be checking some of the things about the machine that we talked about earlier in registration, in terms of the transfer points, or the shafts parallel, or all the wear surfaces in the feeder, the feed roll, scores, pull collars, anything that transports the sheet through the machine. You would really want to check that and see, is it new? Is it the current spec of the manufacturer? And we're controlling the blank at the proper speed.
I think this is a very pertinent question because I go into a lot of plants and I see a lot of older machines running, and a lot of them are maintained very well. But as you said, some of those total rebuilds can be very expensive. And then there's a justification if you're going to spend that money on an older machine. So going through and doing these items and checking the vacuum transfer and other wear parts is a good way to try and improve that registration without paying for the total rebuild.
Yeah, it's always good to remember. It's kind of like sometimes we can get caught up into things with improving the graphics and different new concepts in printing and the more challenging jobs. And in an ultra simplistic manner, and we think of registration mostly in the printing because that's where we've been challenged as an industry to improve our printing technology a lot, and the graphic side, is that the machine is really doing one thing. It is transferring a dot of ink from the printing plate to the proper position on the board. So it has this printing plate attached to a cylinder, and it puts ink on it at one position, and then it transfers it to the board. Now that's an ultra simplistic view of it, but you got to keep that in mind, and what will be the things and the variables that will inhibit you from doing that. And that's when we talk about the speed, the control, the timing, the blank coming through the machine. Any kind of lost motion in the print cylinder, is there variation in that? And you know, your printing plates, maybe you get older printing plates, it's an older machine and the plates are not up to spec. So it's amazing sometimes when you've seen some older machines, even without extensive rebuilds, that are doing some very high quality work, but they've been well maintained and paying attention to the details.
It's always nice to see the older machines running. You know, a lot of people have old Langstons or S&S and they still run them, and they call them the workhorses in the factory.
Yeah, I was always impressed that we won't tell names and tales too, but a customer, I would always come in and admire the machines, and once a month they would wax the machines, not just clean them, but wax them just like a car. All the printed or all the painted surfaces on the exterior, so they look perfectly pristine.
That is some level of maintenance.
Right.
George, I have a question for you here. If I have rolling scores on my Flexo folder gluer, what should I be checking?
Rolling scores are almost a fact of life. It starts with having a proper score for the board combination that you're running. Unfortunately, machines are not built that allow you to select different profiles for different orders. So your best solution at that point is to analyze the various score profiles that are out there on your machine with your profiles, and select the best one that runs for that product mix. This has been done through the years. People have seen improvement because, we back up for a second, the rolling score comes from the fact that the actual crease line never quite makes it to the fluted medium. And if it does, it doesn't make it on the same point on the flank angle, which means one side tends to fold differently than the other. The tighter the flute, the tighter it is because there's less room for that surplus material in the medium to go someplace. So the trick is to find out what works best. And in many cases, it comes down to a best practices arrangement. Scoring runs best when the moisture content's up about 4%. You have sheets that are down about 7, makes the job tougher. That's one example. So you're not going to eliminate them. All you can do is break down and use much like an old fish diagram to figure out what are the things that you can control and what are the things that you can't control, and then find a way to do it.
Some other things.
That,
go ahead, Ev.
I was going to say, I know that people use different size creasing wheels in different machines, but from my experience, one-to-one creasing, where the big creasing wheels are the same size as the print cylinder, that, from my experience, is one of the more effective ways of preventing rolling scores.
Well, that's it. Is if you have your choice when selecting a machine new, the machine diameter creaser not only provides you the maximum amount of rigidity that can be put in, it also allows the rate at which the crease is formed to differ. And you are correct, Evan. Experience has shown that the machines with the larger creasers tend to do better with the rolling score elimination, or mitigation, I should say.
The other thing that we've talked about is in the folding area of the machine, number one is to make sure the rails are perfectly aligned and parallel so that you're trying to fold down the proper line. And again, good pressure from rail to rail. Almost like you take a blank that hasn't gone through the folding section, fold it by hand. The most effective way to make it more perfect would be to put a straight edge firmly on the score line as you do it. And this is effectively what the rails are doing through the folder.
Right. That's why you want to run tight rails. Yes.
And some machines even now have secondary dressing of the score lines in the folder.
That too is correct.
Yeah, I've seen that. Okay, our last question that we had to come in for today. What are the logical reasons not to run faster on my Flexo folder gluer or rotary die cutter? And I think the first and most important part that we should readdress here is that a good box is what's most important. So if you're running a good box at a decent speed and you don't have too much scrap coming through the machine, then you're going to be in good shape. I don't know that you need to increase your speed, because that's when you might start running into more issues with scrap, especially if you're die cutting being carried through the machine.
Yeah, exactly. Good point, Evan, because, we're all enamored with running fast, all the machines, new machines to run faster, but you got to make sure that you're not just creating faster scrap, so it's critical because it can be glamorous, but you've got to make sure it's a good box.
Yeah, it's great to walk up to a machine and see boxes flying through the folding rails. I mean, everybody loves that sight, but if there's as much scrap coming through as there are sheets, then you're in big trouble,
True. You don't want to be producing OCC,
Definitely not. So machine manufacturers usually provide a speed curve, right, for that?
Well, not in my experience, George. It's not real common. There is always one, but I don't see them generally presented to customers,
Everybody has a best practices speed curve based on their own machine and their own knowledge. The industry has never demanded that they be disclosed up front. They all come in pretty close to one another. Mm-hmm. Same thing that'll limit one machine will usually limit any other machine.
I think in general, Evan, the rule of thumb a little bit, as you approach machine limits, whatever those limits would be, maximum, minimums, whatever it could be, you're going to start infringing on those speed curve issues because you're pushing the machine, and therefore you're going to have to slow it down to get it to perform as it encroaches on that limit.
There are some benefits of keeping machine speed high as you approach some of those limits, though, aren't there?
Well, some of the times, in fact, I was telling George, is the old thing about the minimums. If the blank has a lot of inertia to it, it kind of keeps its own flight path moving through the machine. You know, we don't want to get down below the minimums and just count on throwing it into the next nip point, but the inertia of the blank moving through is good. So even though we say the speed curve, machines are made to run at machine speed and run well. You know, it's almost like the old story that everybody's experienced sometimes as a machine guy going into a plant and a guy wanting to know why the machine's not running faster from a machinery standpoint. And then as the manufacturer looking at all the things and everything seems to be fine, and then asking the supervisor, is it okay if I turn the speed up? And then some operator comes over and turns it right down because the machine was making a lot of noise because it happened to have some warped board going through it. And he was frightened it would damage something, I guess. Maybe his intentions weren't good, or maybe he didn't want to load so many sheets so fast. But sometimes there are perceived limits on things and not really realizing how the machine should be built. And this is why sometimes when you have service personnel in, and certainly with new machines, you want to push the machine to its limits and test, just like we were talking about fingerprinting earlier, to know what it can do and know what it cannot do.
Yeah, that makes a lot of sense. George, do you have anything on why they shouldn't run faster on a Flexo or a die cutter?
Well, no, I've always held that it comes down to a combination of, excuse me, housekeeping and another couple of things. Housekeeping meaning if a full die cut sheet that's at the extremes of the machine versus the minimum machines, I might generate as much as more scrap in the same time period. So there comes a point that scrap handling becomes your glass ceiling, if you will. And I've always advised production managers to try running fast and slow down at 5 or 10 minute sheets per minute at a time until you're making saleable sheets, and then just bury it in your mind that when I run this type of work, this is my optimal.
And then George, you know, it's kind of like we were joking a little about it, but the inertia of carrying sheets through the machine. As you run faster, you have more inertia. You also have more inertia with the scrap as it runs faster. So working with your die maker can be critical because you may want to put in rule in there to chop up the scrap some because you don't want big, kind of like paper airplanes flying around, you know, type of thing. So chopping and good die making practice can help you get that scrap down on the scrap conveyor in a much more orderly fashion, particularly if you're going to run at high speed.
Well, that's it. It's like one of my own rule of thumbs is no scrap piece should be bigger than 2 by 2. It allows you generate more pieces, but they're smaller pieces and they tend to want to fall more natural than big pieces that have the inertia that want to go through the machine.
And we're seeing more and more die cut work now, particularly inline on Flexos. You know, having a die cutter inline on a Flexo folder gluer was a rarity. And now it's probably the most common configuration because there are more demands to you know, RSCs with handholds, vents, flap cuts, other things that can generate a lot of scrap.
That's correct.
On a lot of those new Flexos, they're top printing machines and then they're die cutting from the bottom. So that, you know, poses a challenge as far as gravity and scrap. So that, you know, could definitely play into speed and determining why you shouldn't run faster. If you're die cutting laced doilies, it could be challenging to eject all that scrap.
Exactly, because therefore you've got to be more careful on trying to get that scrap down on the scrap removal system right away.
Yeah.
Because sometimes you go in and see some of these machines and it kind of looks like you need the snow shovel brigade down in the folder if you're not careful.
It's a problem down here in South Carolina. We don't have snow shovels.
Oh, that's right. That's right.
Well,
We have no sympathy for you, Evan.
we get an inch of snow or an inch of ice and everything's shut down for a week.
Right.
Big trouble. But, you know, these production roundtables, I think, it's not only fun for us to discuss the issues that come in, but hopefully we can pose some value to the corrugated industry. And, you know, we will probably be welcoming questions from outsiders, you know, and probably have some guests on here to discuss some of these things with us. So I think it's something that we should continue for the foreseeable future. What do you think?
Well, I think it's good, Evan. And then the other thing, encourage people if they think we missed some key points on some of the discussions here or glossed over some important things, or they would like to go in depth on some of the topics that we've already hit on or any other thing, please let us know.
I will. And I've got the link, as I said before, going out through containerboard.com, and it'll also be, the video will be uploaded to our YouTube channel. And through that email blast by Randy Banks on containerboard.com, my email is on there, eclary@ncm-jsmachine. So if anybody watches this, you can email me questions that come up, and then we'll make sure that we go through them later on.